So what I'm going to do is talk a little bit, first of all, pick up on some of the points that Tim's made about some of the global changes. I've decided to structure this talk around the recent past and the way we've perhaps thought about food from a crop production point of view, at any rate, in the recent past. Talk about the immediate future, some of the things which I think we're going to be focusing on now and into the immediate future, and then talk about the longer term future. So to pick up on some of the points that Tim has already made, in terms of global changes, you'll be familiar with many of these, I think. We've got more people, and as Tim said, they're living in urban areas. Many of these people, on average, these people are better off, and they are much more demanding of resources. The middle class of the UK is extremely demanding of resources. We've got the increasing concentration of gases in the atmosphere, greenhouse gases in the atmosphere, changing climate and more variable weather, I'll come back to that later, rising sea level and amplified by geochemical cycles, which are much more open and leaky in systems than they were in the past. And all of these, plus some others, have impacts on the way we produce crops. Tim's already mentioned this definition of food security, and I just want to highlight 2 points. It doesn't, in this definition, talk about producing food at all. It talks about people having access to food, and note also that it doesn't talk about quantities of food. It talks about the nutritional benefits of food. So it's nutritious food that this definition focuses on, and in another life, we worked on this in this definition being underpinned by food systems, which I may talk about a little bit towards the end. Thinking specifically about climate change, and today is a good day to do this, given the output from the IPCC report today. This report in 2012, I think, drew together quite a number of the issues that Tim has been talking about. This was a commission that was chaired by John Beddington, and it talked about the issues that were facing the world in relation to climate change. I've just picked out 3 things to highlight from that report. The first is that it actually called for reinvestment in agricultural and food research. Particularly, it pointed out the divestment that's occurred within the public sector in many of the developed countries, and the role that public, together with private investment, could play in developments in agriculture over the next decade. It talked about sustainably intensifying production, again to pick up on a point that Tim's made, but reducing negative environmental impacts. And it talked about reducing loss and waste within food systems. So how are we going to go about doing all of that? Well, I'll start the story of the recent past, the last 50, 60 years or so, with this slide published in that paper by Godfrey in 2010. And what this showed was that since 1960 through to 2010, the relative production of many grains, particularly wheat, barley, maize, rice, and so on, had increased by the total production had increased by somewhere around 2.5-fold, 250% or so. What I want to draw out of this figure is, and the bit that doesn't very often get talked about, are these crops down here. So the coarse grains, the ones that grow in particularly dry conditions, there's hardly been any increase at all. And in root crops, such as cassava and potato, there has been a little increase. This is now at about 1.3, a 30% or so increase relative to 1960 in terms of total production. And the message that I draw from this, or one of the messages that I draw from this, is that we've become much more dependent in our food systems on cereals. The cereals, rice, maize, and wheat in particular, and much less, our diets are much less diverse in these other crops than they were previously. And this carries with it, and this feeds on what Tim said just now, it's well known that these crops here are certainly pretty energy dense. They also contain quite a bit of protein, but they're quite poor in many other vitamins and minerals. And there are growing concerns, for example, around the world about issues such as zinc. And I'll come back to that at the end of my talk. But I draw from this our very great reliance on these grains here relative to these crops here compared with where we were back in 1960. If we look at how that production has come about, and Tim has already said there's no more land. Well, there is a little bit more land that's been brought into production over that 50, 60-year period. But essentially, we've done that by increasing yields per unit area. And these are global yield trends over this period here. And they're approximated by linear regressions here for all three of these crops. On average, those cereals have increased, yields have increased by on average, about 50 kilograms per hectare per annum. This sort of slide has been widely shown. However, if we look towards this end, there were disturbing trends already evident in the period around 2000. We now have increased concerns around that. By and large, when you look at those increases in yield, they've incurred in a linear fashion. The big exception to that has been Australia. In Australia, there's actually been a series of quite marked steps upwards as particular practices have been followed. And actually, they've been adopted quite rapidly. So there have been a series, for example, from the 1860s through to 1900, you had this period of resource depletion. You then had a period of fallowing, mainly, then a period of phosphorus, and then getting the nitrogen right. But Australia is a sort of exception that proves the rule. By and large, the pattern is of linear increases. But increasingly, we're seeing no increases or only very slight increases at all. These are UK wheat yields. And in essence, although during the 1980s, in fact, it comes back right back here, this linear increase occurred at about 100 kilos per hectare per year, up to around the early 1990s. Essentially, it's been flat from that point onwards, as have yields of rape. So our two major arable crops in the UK, yields have been effectively the same since the early 90s. I'll come back to some reasons for that maybe in a moment. And in a recent paper published by Ken Kasman and his group, they've looked at a whole range of countries and a whole range of crops to determine whether these increases in yield are continuing or whether actually we're hitting the buffers. You can see in this slide, this is for wheat yields, there are a number of countries, particularly within Europe, that have all hit this plateau at roughly the same time. The Netherlands, the UK, and France, we're all sitting now basically on level yields. Yields are continuing to increase in China, and there's a much lower plateau here in India. For rice, too, in certain countries, such as California in the United States and in the People's Republic of Korea, there are plateaus. In other places, yields are still increasing at a linear fashion. In Indonesia, after the early grains from the Green Revolution, again, they're approaching a plateau. The only one that seems to buck the trend with yields still increasing in the main is in maize around the world, although even in Italy, those have reached the plateau and so on. And if you take those figures overall, and for the analysis, the meta-analysis which they did, they were looking at a combination of countries and crops that covered roughly 70% in total of global production. So of that 70% of global production, about a fifth of the area is now at some form of plateau. Yields are not increasing. In some places, there's a very much slowed rate. And you can see that that this is similar for rice now, either at a decreasing rate or already reached a plateau, about 40% of the total area producing rice, and for wheat, about almost between a quarter and 30% of the area producing the crop has reached a plateau. And so we cannot rely, or we cannot think, I think, at the moment, that we can just assume that increasing yields is going to produce us the additional food we need. Now, in the UK, as I've said, yields have been essentially static for just over 20 years. But if you look at the recommended list, if you look at the trials that are done to trial new varieties of wheat, yields in these trials continue to increase. In fact, they've been increasing at about the historic rate. So these are different groups of wheat going through from hard wheats to soft wheat, and all of them in these trials show genetic improvement. So genetic gain is occurring in these trials, but it's simply not translating into the field. So this gain on average is at about 50 kilos per hectare per year, which is very similar to that overall historic global trend that I showed you earlier. But as I say, it's not getting through to the field. Now, why is that? And the truth of the matter is, nobody properly understands why that is. One of the things, one factor has been that, as with most of Europe, we've had a slight increase of sunshine during June, but our grain filling duration, because of changing weather, is reckoned to have declined by about 3 days since the 1980 because of rising temperatures. In other words, we've got a slightly shorter grain filling period. If you go to France and you read the French literature, they will suggest that it's also because they've got hotter summers that their yields have levelled off. If you go to the conferences that I go to with soil scientists, they'll say, aha, it's because we haven't increased nitrogen applications since the early 90s because of the water framework directives. And I was at a meeting the other week where somebody said, oh no, it's nothing to do with that. It's because the government changed our whole advice structure, and all of our ADAS and so on was dismantled in the late 80s, and we've not had the ability to translate our research into the field effectively since the late 80s, early 90s. And basically, you can take your pick as to those and a number of others as to what is the cause. But the fact of the matter is, we have not seen any increases in yield in the UK and much of Europe, France, Netherlands, and so on, for nearly 20 years now. And why is that? And I think part of the answer, and part of the answer comes in an HGCA report that I took that last slide from. Part of the answer comes from something which, in many ways, we seem in the UK to have forgotten, and it goes back to Tim's point of yield is a consequence of genetics, environment, and management together. And getting these things right together is not easy. Lloyd Evans, in his book, pointed this out in 1993, that the Green Revolution wasn't just about semi-dwarfing genes, although they unlocked the ability to use a number of other technologies. And if we look at what drove those yield increases in the 70s and 80s, it was getting all of these technologies working together that led to many of the increases in yield that we saw. And again, going back to my own background as a soil scientist, we knew about nitrogen and phosphorus fertilizers in the 1860s and 1870s, but they didn't get used effectively until the 1940s and 50s onwards. And they couldn't be because we didn't have, at that point, the right varieties. So getting all of these things together is really important. If we move on now to look at, and Tim alluded to the desire to increase yields and get closer to the potential and to the genetic potential that is there. There have been a number of analyses now of why is it that we're not getting those higher yields in many parts of the world. This is an analysis that I like quite a lot because it actually took a systems approach to things. And they looked at, again, wheat, rice and maize around the world. And they looked at the basically how much less production was occurring relative to a theoretical potential yield. And the aggregated yield gap was 43%. It was 60% for maize and 47% for rice. But in their analysis, what they demonstrated was that in different places, in different parts of the world, there were different factors that were the principal causes of those losses of yield. So, for example, here in the United States, it was actually the question of getting access and irrigation that were major determinants. Over here in Ukraine through and into central Russia here, accessibility again and labour. And over here in China, the slope of the land posing constraints together with irrigation. And again, to pick up a point that Tim has made, these technological, if you like, things which are looked at in terms of technologies are often influenced by complex social, economic and political processes. Lobel also conducted a meta-analysis looking at why yield gaps occurred. And one of the more interesting points, I think, of this was that in many irrigated cropping systems, fairly consistently, yields stopped improving once you got to about 80% of the potential. Getting the extra 20% is extremely difficult to do. So, what about the future? Coping with those global changes and producing more food with less resources. Just a point to make is that if you want to look at the effects of climate change and the changing climate, one of the best places to look is actually in the insurance industry, not in agriculture at all. If you want convincing that climate change is having an effect, look at the insurers. This is from Munich Reinsurance. They basically take the losses. Look at how catastrophes, the changing catastrophes that they're insuring around the world have changed since 1980. In terms of geophysical events such as earthquakes and tsunamis and volcanoes, a slight upward trend, but not very much. These are down to storms, meteorological events, and hydrological flooding. Those are the things, those are real. Okay, how can we go forward and what might plant science have to offer? So, and again, I didn't expect Tim to say this, but I think it's absolutely right. And I put it in I'd say that, wouldn't I, because I put it in my talk. Actually, we need to be looking at a much broader range of crops. And I've picked a particular example here, the potato. Potato is the third actually most widely grown crop in the world. If you go into the literature and you want to improve resource use efficiency of potato, you'll find that most of the irrigation, something like 80% of all the irrigation applied to horticultural crops in the UK is going to potato. It's one of the most susceptible to shortages of water. But if you go into the literature and you type into Web of Science potato roots or something like that, you'll find there's about 20 references. That's what we know about potato roots. So it might be worth, don't you think, having a look at how some of these important crops actually work and roots. And so this is a picture of a potato root system. Very interestingly, and we didn't sort of know this before till we started the work at SCRI up in Scotland, James Hutton Institute now, The potato produces basal roots here near the mother tuber, and it also produces roots here at the junction between the stolon and the stem. And if you start to look at a whole wide range of materials, so these are Foreca potatoes and tuberosum materials and crosses between them, these stolon roots are actually a significant proportion of the total root length. And there is significant variation between these lines and genotypes. Some are varieties. And in a further study, what we found was that if you look at the yield of these potatoes, you look at it in terms of the yield in droughted conditions relative to irrigated yield, the ones that did best in the dry conditions were those that had many more, a much greater root length coming from those stolons. That's just, if you like, simple observation. Takes a lot of work to do that sort of science in the field, but it starts to produce, I think, interesting pointers to the future. We also, I think, need to start looking again at systems, ecological systems and managed systems. This is a picture of a farm in central Kenya. It's a mix, as you can see, of maize, of crops. In fact, there are other crops in here as well, and trees. And this landscape is actually pretty good at mopping up nitrogen fertilizers. Again, in this environment, the nitrogen is mineralized as soon as the rain comes, so you get a burst of mineralization. If you're planting a crop such as maize, you also plant it shortly after the rains. The crop demand lags behind the mineralization, so the nitrogen can move down the profile. If all you have is shallow-rooted crops like maize, this pulse of nitrogen can be moved beyond the rooting depth. If you've got trees and bushes within the landscape, it can access that material. And that's shown in this slide here, where we looked at the nitrate N. Under maize, you get very much higher concentrations, all the way down to nearly 4 meters than you do beneath the bushes. I wanted to pick up on another point that Tim raised, which I think is incredibly important for the future. We're not just going to be interested in yields, we are going to be interested in the nutritional quality of the materials that we're producing. This is an example from the industry that I'm in at the moment. We've known for a long time that if you add fertilizers, in this case it's phosphorus, if you add phosphorus at different rates, you certainly increase the yields, but one of the consequences is that the concentration of other minerals, particularly things like calcium and magnesium and zinc and so on, decline as you push up the yield. In other words, you're getting the yield, but the relative concentration of nutrients declines. And we will need, I think, to make a great deal more effort in looking at the nutritional quality of the product that we're making. So just to finish off, another area, and it's related to that, where we're starting to do more work, is to look at that nutritional quality, to look at what happens through the supply chain. We've just started a little bit of work at East Malling with tomatoes, following it through from the production in glass houses right the way through to the supermarket shelf. This is a very early work yet. We can see the decline in, for example, the firmness of the fruit as we go through from harvest through the store and into the supermarket. We're following up on sugars and so on, but that's at a very early stage. And my final point, to get within the 25 minutes, my final point to make is that in all of these changes that we are trying to make, we've got one other further little conundrum. And that is, how are we going to sustain yields, never mind increase them, while reducing the amounts of energy we put into the system? And this is just a bringing together of some information that's in this book, that as basically, these are, you can see, for maize and for rice, as we've moved from essentially subsistence agriculture with human labour to mechanized tillage and mechanized inputs, We've certainly increased yields by a factor of around, in this case by a factor of around 4, in this case by a factor of around 3. But look at what we've done to our inputs of energy. More than 10-fold increase in energy input here, and an 8-fold increase in energy here. So that the energy ratio, the energy of what we put in to what we take out, has declined substantially. And there are now parts of the food chain in North America where if you add in the storage costs and the distribution costs, we're basically only getting from the sun, or rather, we are using the same amount of energy from fossil fuels as we're getting back from the sun. That energy for the system is around 1. Is this a smart way to be conducting agriculture and food systems? I think not. So, to conclude, you can read these for yourself. We're going to need multiple approaches. These yield gaps, because we need G times E times M, we actually need agricultural sciences, not just plant sciences. We need to produce more with less, and in many ways it's not easy to see the way forward at the moment. And personally, I find that question about how are we going to increase the amount of energy we get back out of the system a very key one. That's it. Thank you.